Hello friends, welcome to Weathercast. Today I'm going to talk about an interesting weather feature called the jet streams. And along with that, I'll also talk about the extratropical storms that the jet streams bring along with it. I'm pretty sure that many of you would have heard this term jet stream. If you are taking a transatlantic flight, then the pilot announces that they are flying through the jet stream. Or even if you take any weather chart, you can you can see these jet streams in those charts. So what are they, and how do they impact the weather, and how do they bring along these extratropical storms? That is the focus of today's video. So let us start with what are jet streams. These jet streams are nothing but fast moving narrow band of air, and they predominantly move from west to east. So they are westerly air parcels, and they move between 30 to 60 degree latitude. All right, and they also are present high above the altitude or high above the ground. And if you go closer to the troposphere, you will experience these jet streams. So approximately if you move 10 kilometers above the ground, then you will experience the jet stream. Typically, jet streams are divided into two types: the polar jet stream and the subtropical jet stream. The polar jet streams are the strongest compared to the subtropical jet, wherein the average speed of the polar jet stream is around 150 kilometers per hour. That is the average speed, but sometimes they can become as strong as 400 kilometers. So it is the average, and that's the gust. So sometimes, depending on the physical aspects, the polar jet stream can be as strong as 400 kilometers per hour. So you can see the amount of impact, or you can see that it traverses the whole globe, right? So that's the reason why you can see this as a narrow band of air covering the entire globe and moving at very high speed. Subtropical jet streams are generally slower, maybe 100 kilometers per hour is the average speed, and they can get as strong as 200 kilometers per hour. Apart from these two jet streams, these two jet streams that we discussed just now, the polar and the subtropical, those are the permanent jet streams. So they are present throughout the year. And there are other jet streams as well, which are called temporary jet streams. And those temporary jet streams can be classified into two subdivisions, namely the tropical easterly jet, or also known as the African easterly jet, and the Somali jet. We will discuss all these types in detail in the next coming slides. So these are the secondary or the temporary jet streams. So I have shown it here. So unlike the permanent jet streams like the polar or the subtropical jet streams, these jet streams are more local. So the temporary jet streams are more local and as well as short-lived. So the Somali jet, which forms during the southwest monsoon, is a jet stream because anything which is narrow and fast-moving is a jet. And it is if that feature sustains for a substantial period of time, then actually you can call it as a jet stream. Okay, but the Somali jet is a feature which only sustains for 4 months during the southwest monsoon, starting from June till September. That's why it is a temporary jet stream. But it is nevertheless a jet stream because it is again a narrow band of air, and it is very fast moving. Average speed of the Somali jet is around 25 to 30 kilometers per hour, and it can go as high as 60 kilometers per hour. And it is not as dominant as the permanent jet streams, or the Somali jet is not as dominant as the polar or the subtropical jet, but nevertheless it plays an important role during the southwest monsoon. The second temporary jet stream is the tropical easterly jet. Okay, this tropical easterly jet again is a temporary feature which forms during the southwest monsoon, and it actually aids in the circulation of the southwest monsoon currents, and that's why they are quite important. And once again, they are short-lived, but they are fast-moving, and they are very narrow band. Okay, narrow band is in the sense that compared to the meridional extent of the Earth, which is from -90 to +90, these are very narrow. Okay, so you can see that vertical expanse is so large, and this is a very tiny narrow band which is present in the atmosphere. That's why we call it as a narrow band. And the other thing that demarcates these temporary jet streams from polar jet streams are the height. These are low-level jets. Somali Jet and Tropical Easterly Jet are low-level jets, and they're usually seen at around 2 to 3 kilometers above the ground. Okay, maybe sometimes maximum 4 kilometers. All right. So these are low-level jets, and that's why these are very different compared to the permanent jet streams. So nevertheless, let us look at the physics behind the formation of a jet stream. One of the most important aspects is the heating. Okay, so we all know that there is a temperature difference, meridional temperature difference going from zero equator. I'm only going to focus on the northern hemisphere. It is very symmetric. So whatever happens in northern hemisphere will happen in the southern hemisphere as well, in the sense that a polar jet stream is present in northern hemisphere. Similarly, a polar jet stream is also present in the southern hemisphere. But for convenience, I'm just going to take the northern hemisphere in this lecture. So you have temperature gradient, which is equator is hot, poles are cold. So as soon as you have that, there is a energy transfer, which is in the form of convection from equator to pole. So from south to north. So this, what happens is, this kind of pushes the warm air towards the poles, and the polar cold air tries to come, because from continuity, whatever rises up, something has to come to fill that place. So then there is a circulation cell that is created. Okay. So first thing that you need for a jet stream formation is temperature gradient. And if you, just as an off topic, if you take the temporary jet streams as well, these also form because of the differential heating of the land and ocean. So there is a heating in the Tibetan plateau, there is a cooling due to upwelling, and that kind of creates a jet. Okay, so first important aspect for any jet stream is the heat gradient. Okay, there should be a differential in the heating, and the stronger the differential in the heating, stronger is the jet stream. Okay, so that is why the temporary jet streams are not as strong, because the temperature gradients are not very strong, whereas permanent jet streams are very strong because the temperature gradient is very strong. You can see the stark difference between the hot and the cold fluids. Now, along with that, you have the Coriolis force. So what happens as the air rises from the equator, because the parcels in the northern hemisphere should be deflected to the right, so the easterly winds become westerly winds. That's why you have these westerlies. And we all know that jet streams are west to east, and they exist anywhere between the 30-degree latitude to 60-degree latitude. Okay, so the Coriolis force deflects these air parcels to the right. So the easterly winds, the trade winds near the equator, become westerly winds at the mid latitude. Okay, now how does the speed come into picture? All right, I understood that a temperature differential is required to get the jet stream initiated, and the westerly motion of the jet stream is because of the Coriolis force. How does the narrow band of fast moving, how does these air parcels attain a very high speed? The answer lies in the momentum transfer. So what happens near the equator is, the equator parcel near the equator gains the angular momentum, okay, and it kind of loses it near the mid latitude. So it gains a momentum, and it transfers that momentum to the air parcel near the mid latitude. And momentum is nothing but the push. Okay, so if I say that I have a momentum, I mean I'm moving very fast. Okay, so the transfer of momentum from the equator to the mid latitude results in the fast moving stream of air, because whatever angular momentum was gained, it is lost here, and that transfer of this angular momentum is shown as a fast moving gust of air at that particular mid latitude, which is 30 to 60 degree. Okay, so you have the subtropical jet stream and you have the polar jet stream. So this is where the strong winds come from, because of the momentum transfer. So now I hope the process of jet stream is very clear, how it forms: temperature gradient, Coriolis force, and the momentum transfer. All these three work together to produce what is known as a jet stream. And this is a typical jet stream that I have shown here. The warm air rises up, cold air comes down, they meet at some point, and that is where a narrow band of fast moving air is created, and it moves from west to east. The two different permanent jet streams are polar jet stream and subtropical jet stream. Now, another important concept is the undulation of a jet stream. Okay, so let us say that the jet stream has formed because of these temperature gradients that we discussed, because of momentum transfer, and because of the Coriolis force. The jet stream has formed and it is moving from west to east. So this is the cold polar air, and this is the warm tropical air. Here, for all purposes, for simplicity, I am just considering one jet stream, which is the polar jet stream. Okay, there will be another jet stream, which is the subtropical jet stream, but we are ignoring that for now because the concept is the same. Undulation of any jet stream can happen because of the physics that we are going to discuss. So this air, as it is moving, because of some instability between the cold and the warm air, okay, what happens is they start to convert themselves into a wave. So this blob that is there now starts undulating and starts becoming into a wave, creating a trough and a ridge-like structure. So trough is nothing but the air which is moving down and creating a cyclonic circulation. Remember, northern hemisphere anti-clockwise motion is cyclonic circulation. So it creates a cyclonic circulation, and a ridge is nothing but air which is creating an anticyclonic circulation or clockwise motion. Okay, so as this is moving down, it is kind of tracking a clockwise, and then it has a ridge, has a trough. So dipping is trough, and moving up is ridge. Okay, so it creates because of the instability, the warm air and cold air front creates an instability, creating trough and ridge kind of feature. And as this instability keeps growing, the parcels break. So this blob of air breaks down into a low pressure and a high pressure, and these low pressures and high pressures are the ones which govern the weather. Okay, so because of the instability that is forming, initially there is a trough and a ridge formation, and because if the instability sustains for a very long time, then the waves pinch off from the parent parcel, which is this big blob. These things pinch off, and then you have the formation of low and high pressure systems, which then govern the weather. And once this pinch off happens, then this parcel again go back to one, takes this shape, and again an instability occurs, and again this thing continues. So this is not it is not a one-time process. This can happen multiple times. After pinching, you again start from step 1 and go through 2, 3, and 4. So multiple times a low pressure and high pressure can be produced, and of course, as we all know, low pressure is what results in bad weather. Okay, and so that's why as soon as you have this trough pinching off, and we have to track the moment of that low pressure where it is moving, and there the weather is going to become bad, either a snowstorm or a hailstorm or very cold conditions, whatever. Okay, that is what is going to happen. So undulations of jet stream is very, very important aspect, and it's a topic of research. Okay, but this is the concept why it undulates. So of course, these two jet streams that I talked about, they keep undulating. They don't move as one steady mass. They keep undulating, except during summertime. What happens is these jet streams actually move as a steady mass. Like, they don't undulate much, because the reason is because during summertime there is enough spatial gradient of temperature. So during summertime there is a lot of heating near the equator, and there is a lot of cooling near the poles because the sun's radiation don't fall there. So there is a big gradient which leads to a nice blob of parcel, okay, which is like this. It's during the winter time, what happens is the gradient in temperature reduces. As soon as the gradient in temperature reduces, the undulation starts, because it is not enough. That's because the instability starts producing. Instability starts occurring, because what happens is if the gradient reduces, that means this is getting colder, this is getting warmer. Anomaly. Okay, so compared to the warmth that it has, the warmth has reduced. Compared to the cold that it had, the polar region had, the cold temperature has reduced. Okay, so in the sense that this has become a little bit colder, this has become a little bit warmer. So it creates instability, because instead of warm air just moving and cold air just coming down, now what happens is warm air from poles starts coming down and cold air from equator can start moving up, triggering an instability and leading to undulating movement. That's why The undulation of jet stream is very very common during winter time, and that's when you have the most amount of inclement weather either in the North America or US, like North America like US, Canada, or Europe like UK, Germany. These places have very harsh winters, because the jet streams can ensure that they bring a lot of cold air from Arctic to low mid latitudes. Okay, I hope it is clear. So let us get a little bit deeper. Subtropical jet stream, the production is the same mechanism: temperature contrast, Coriolis, and momentum transfer. During the summertime, should be summer. Sorry, it is continuous in the sense that during winter it is continuous in the sense that it doesn't break itself. Okay, so during summer it is continuous. During winter time, it can undulate. Okay, and what happens is in the northern hemisphere, the subtropical jet stream will move north during the summer. The reason is because the ITCZ is moving north. So as the ITCZ is moving, or the Hadley cell is moving north, the entire jet stream, subtropical jet stream, will also get shifted up. So during the summer time, it is above its normal position, and during winter time, it is in its normal position at 30-degree latitude. Okay, but during summer time, it is at 35 or 40-degree latitude, and it is important to have that because then only the monsoon currents can propagate. So it is a very beautiful weather dynamics wherein everything adjusts. Like as the ITCZ is moving up, the STJ or the subtropical jet also has to move up. Okay, then only the ITCZ can move. Okay, it is like a wall. Like let's say two walls. Unless one wall moves, unless the subtropical jet moves, ITCZ cannot move up. Correct. So it's a beautiful dynamics, at least to me. This subtropical jet during winter times can be displaced when a strong polar trough can extend into the subtropics. This is the other reason why North India can get harsh winters, because the subtropical jet can get displaced because of the polar trough. Again, the undulation of this polar trough can cascade into the subtropical jet, and the subtropical jet can also undulate more to produce inclement weather to tropical regions. So it is not true that tropical regions cannot have harsh winters. It is possible. Okay, so a country like India can have harsh winter if the polar jet stream dips too much, which has a cascading effect on the STJ, which is the subtropical jet, and that can cascade a very cold air, which can come down as low as 15-degree latitude. Okay, that means as down as central India. Okay, so it is possible. And like I said, STJ is closely connected to the summer monsoon, because unless and until the STJ moves up, ITCZ cannot move up and monsoon cannot start covering the Indian subcontinent. So STJ has a very important bearing on monsoon. Polar jet stream, a very very important phenomenon or feature. It is produced again by the temperature difference, and it is very closely related to what we all know as polar vortex. So it has also a variable position, just like the subtropical jet, but it varies more than the subtropical jet, because in the summer it shifts towards the pole, so it shifts more upwards, because again there is summertime heating near the equator that pushes the jet stream upwards, and during winter it moves slightly down towards the equator because of the cooling near the equator. Like I said, the gradients in temperature decreases and it can move down. So the jet is a strong and continuous feature in summer, just like the subtropical jet. During winter, it shows undulations, and that undulations is also known as the North Arctic oscillations. So during winter time, every scientist is on the lookout for this North Arctic oscillation, because that is going to determine how harsh the winter is going to be. If the polar jet stream doesn't shift too much south to the close to the equator, or if it doesn't shift too much from its original position, then that means the winter is not going to be harsh. But if it shifts down or it undulates a lot because of the instability, then the climate of North America and Europe will definitely get influenced. And because of this cascading effect that I talked before, like the polar jet stream undulating down can cascade to the subtropical jet stream moving down, and that can in turn affect India and other tropical countries. Okay, the path, speed, and intensity. So other thing is, this polar jet stream can kickstart an extratropical storm like a western disturbance or a polar vortex. Everything that we talk about these extratropical storms, like western disturbance for India or polar vortex for US, Canada, or Europe, it is tied to the polar jet stream. The path is basically how much it is undulating, The speed is, if the speed is fast, then it will not undulate too much. If the speed is low, then it can undulate a lot. Intensity is determined by the instability, how much low pressure, how intense low pressure it can produce, because intense low pressures can create a very drastic weather. Okay, so polar jet stream is the one that determines the intensity of the extratropical storms and like western disturbances or polar vortex. Temporary jet streams we already discussed, Somali jet and tropical easterly jet. These two, this and this. They are not too common. They are only common during the summer monsoon. Somali jet again moves from west to east, whereas tropical easterly jet moves from east to west. These are low-level jets, like I already discussed before. Somali jet is a major cross-equatorial flow from South Indian Ocean to Central Arabian Sea and to India, and it helps in bringing a lot of moisture to India and hence a lot of rain to west coast of India. It is very intense during the June to September months. Tropical easterly jet is a very unique and dominant feature. It is mostly only present in the northern hemisphere during summer, and it is near the tropics, of course. And it is very persistent during the summer months, and it aids in providing a secondary circulation to the monsoon currents. So it plays a very important role in circulating in the circulation of monsoon currents. Without these TEJ or tropical easterly jet, monsoon circulation is not possible. Okay, and the TEJ forms because of the movement of the Hadley cell or ITCZ, which is the intertropical convergence zone. Because of the heating near the Tibetan plateau, the entire cell is pulled up to the north, and that creates this tropical easterly jet during the summer. During the winter, the Hadley cell moves back to equator, thereby getting rid of this TEJ. That's why these are very ephemeral features. Like they are not present permanently. They are only for a few months. Jet stream and weather, this I have already talked. Because of the undulations, the jet stream can break down into eddies, and low pressure and high pressure systems can be created. Low pressure, of course, is important for violent weather, and that is what brings these extratropical storms like polar vortex or western disturbance during the winter times. How does a polar vortex work? It is all dependent on how stable the polar vortex is. If the temperature gradient is very strong, if this is warm and this is cold, or it is very warm and very cold, then the jet stream will not undulate. It will be a continuous feature and it will be very stable. All the cold air will be contained near the poles. It cannot move down because this warm air is pushing the cold air to stay there. Okay. However, if this temperature gradient reduces, so if the equator cools a little bit and poles warm a little bit, I know what you are thinking, global warming. Exactly. The only way poles can heat up is because of global warming, ice melting, all these things that is happening, and that's the reason why the jet stream, polar jet stream, is getting undulated. That's the reason why we are seeing extreme weathers every winter. This is like precisely the reason. The reduction in the temperature gradient is the precise reason why we are seeing frigid conditions or extreme winter conditions in every place, be it mid-latitude, be it tropics. Because like I already said, the polar jet stream, if it undulates, it can create a cascading effect to the subtropical jet stream as well. This is exactly what is the thing. So because of undulation, these air masses, the cold air masses, can pinch off from the parent mass and they can move anywhere they want, and thereby they can bring in very, very cold weather, snowstorm, hailstorm, extreme snow, extreme hail, extreme rain, extreme winters. Everything is possible. The last thing that I want to discuss is the extratropical storm. Polar vortex is also an extratropical storm. Western disturbance is also an extratropical storm. The generation of western disturbance is slightly different. What happens is there is a high pressure, which is the ridge. So like I already told you, the trough is a low pressure, the ridge is a high pressure, right? So there are oscillating low pressure and high pressure systems which are moving along the path of the jet stream. So a high pressure ridge gets set up over Ukraine during the winter time. This, what happens is, because of the high pressure, the warm air is present there, and this warm air has a lot of moisture that interacts with the cold air, so it forms a cold front, and that cold front, since these are westerly winds, of course, the jet stream is a westerly, subtropical or polar jet stream is a westerly moving wave pattern. So as they move, Ukraine is somewhere here, as they move, the cold air and the warm air collide, and because of that it creates updraft. Because of as the two air masses meet, the warm air begins to move upwards, As the warm air begins to move upwards, it has a lot of moisture, so it results in formation of clouds, and these clouds pick up a lot of moisture again on its way from the Mediterranean Sea. They move all the way from the Eurasian place to Afghanistan and to India. So that is the western disturbance. Again, the reason the western disturbance forms is because of the polar vortex dipping down, creating a high pressure over Ukraine, and the subtropical jet again cascading down. The effect is cascaded to subtropical jet, and that subtropical jet moves, creating a front, warm air and cold air front, and that front, as it moves, it creates clouds and brings a lot of rain. That's why cold weather and rain, because the cold weather is because the cold air is mixing, right? So that's why you get cold air and winter rain. One thing very important to note here is that as these storms are moving in, it's a storm because it's a front, right? As the two fronts move, as the two air parcels meet, they create a upward draft, and that's a front. That's a storm, okay? Because it forms clouds. One very important thing to note is that these storms can intensify as they come near Afghanistan because there are mountains. These mountains aid in uplifting these clouds and also providing some amount of moisture from these barren lands, and that could again intensify before coming to India. That's the reason why sometimes you have very intense western disturbances starting from all the way from November end till March, April, sometimes going into May as well. Okay. The reason the western disturbances have increased is because of the heating in the poles. The heating in the poles doesn't want to keep the polar vortex stable. So now, because of the global heating, the wavy polar vortex can extend very longer into the season, all the way up till even sometimes May or June. This year, even in June, we saw one very weak western disturbance. So these western disturbances have increased in intensity as well as increased in frequency, and they have also extended the duration of these western disturbances. All is because of the dipping of the polar vortex, which is the wavy polar vortex. The stable polar vortex is now for a very short period of time because of this heating differential is reduced. Okay, so I hope I'm making sense. Okay, so this is the classic western disturbance. It is a polar jet driven thing, but then it cascades through subtropical jet. Okay, because it is coming to, so it's a tropical storm, right? So it has to come through subtropical jet stream, but the subtropical jet stream picks up the energy from the polar jet stream. So polar jet stream is the mother of all these extratropical storms. Alright, so before I wrap up, very important difference between a cyclone and an extratropical storm. Tropical cyclones form near the equator and they move from east to west, whereas the temperate or the extratropical temperate cyclones are also known as extratropical storms, like western disturbances or polar vortex. They move from west to east always, and they don't have to form near the equator. They can even form near the poles or near the mid latitude or even near the subtropics. These tropical cyclones affect a very small area because they are a very fast moving spinning mass of air, okay, whereas temperate cyclones affect very large area because they move in waves, or they keep moving, right, because it's a jet stream effect, whereas these cyclones are more like a created effect. Okay, they form over ocean with because of convection and high sea surface temperature and all these things. So they're much more localized feature, whereas these are global features, the extratropical storms like western disturbances. The velocity in a cyclone is too high, it can be damaging, whereas the velocity in extratropical storms like western disturbances is comparatively lower. It will create damage, but it will not, there is no need for evacuation or anything. Tropical cyclones form mostly over sea, whereas extratropical storms can form both over sea and land. A tropical cyclone lasts for 7 to 10 days, whereas this can last for 15 to 20 days or even a month. In the sense that within a month, you can see multiple western disturbances. You can see western disturbance within a 1 week period, or you can see 2 western disturbances in a 2 week period, or so on and so forth. So the occurrences are too frequent. So I hope it is clear what is a cyclone and what. So if somebody says extratropical cyclone, please don't get worried. Don't say that, oh, cyclone is coming. No, it is a extratropical storm, like western disturbance or a polar vortex. Okay, so it is not going to be as damaging as a cyclone. So there are many people who say temperate cyclone or extratropical cyclone. Please understand that those are jet stream based cyclones. Okay, which is this part. Finally, how to find jet streams on map. Jet streams are typically seen on a 300 millibar map. You take any 300 millibar map, you will see the jet stream. This is during the summer time, where the jet stream is a continuous moving mass of air. There is no undulation, nothing at all, because the gradients are very nice, warm over equator, cold over poles. So nice gradient resulting in a high speed, high moving mass of air without any undulation. As soon as the gradient reduces, then the speed will reduce, resulting in undulations, resulting in instability and undulations. Other thing is that signature of jet stream, or the imprint of these jet streams, is also seen at 500 millibar. Okay, so which is 5.5 kilometer above the ground. 300 millibar is around 9 kilometer from the ground. But if you look at 5.5 millibar, the imprint of these jet streams is also seen. So if you, I mean, theoretically speaking, if you want to track the jet stream, so here in this case, so this is the subtropical jet stream, and above this is polar. So this is the polar jet stream. You can see very fast, whereas subtropical jet stream is kind of weak. Like the white is strong, blue, I mean this color is weak. So subtropical jet stream is slow moving. Okay, this is the polar jet stream. So this is 30 degree, this is 60 degree. Okay. But if you look at 500 degree millibar level, then the signature of these jet streams will be seen. So even if you look at 500 millibar level, you can track polar vortex and western disturbances. But my suggestion is to look at both 500 millibar as well as 300 millibar to be sure about an upcoming polar vortex or a western disturbance. Okay, so that you can be sure to predict the weather. All right. All right. So that is this. I think is the last slide. Do I want to say anything else? No, I don't think so. Okay, so yeah, so this is the overall basics of jet streams. There is much more to jet stream than what meets the eye, but this is the basic overview that I have given. So I hope you found it useful. I hope this helped in clarifying what is a jet stream, how does it help in bringing extratropical storm, how to track polar vortex, or how to track extratropical storms like western disturbances. I hope you can now forecast these things and be well aware of the weather that is coming to you. One thing that you must see is undulations in the jet streams. Undulations will tell you a lot about what kind of weather is going to come, and especially during winter. During summer, jet streams hardly undulate, but during winter, they definitely will undulate. Okay, so thank you for your support, and please subscribe to this channel for regular weather updates along with the dynamics, and please support me in this venture. Thank you so much. Have a great day.